Today we will discuss some example programs. After that we will move to a topic called recursion. So here the program is programmed to check whether given number is palindrome or not. Saksham Sedu.
Yes,
Saksham,
sir.
what do you mean by palindrome? Do you know what is a palindrome?
No idea, sir.
Okay. So palindrome means a number, and if its reverse is same, then we can say it is a palindrome number. That means suppose 1, 2, 3. Sorry, 1 to 1. If you write the reverse of 1 to 1, it is also 1 to 1. So such numbers are called palindrome. In English, something like noon. It is also palindrome. N-O-O-N. Here from left to right also N-O-O-N. Similarly, madam. So these are the examples for palindrome. Anyway, in this program, we are only dealing with numbers. We are checking whether a given number is palindrome or not. We are only checking whether a given number is palindrome or not. So first I will explain the logic. Then we will move to the program. So we have to extract these numbers one by one. First I have to extract 1. Then I have to extract 2. Then I have to extract 1. Adidev, can you
Yes,
hear?
sir.
So
Yes,
Adidev,
sir.
from 121, can we derive 1?
121 1 drive identical.
From which operation we can extract 1 from 121? Adidev.
Yes, sir. ഓർമ്മയിട്ടില്ല sir.
Okay. Advait,
Yes, sir.
so how to extract 1 from 121? If you perform any
Modular
modular,
operation.
okay, modular operation. 121 modular what?
Modular 10.
10. Okay. 121 modular 10. Very good. So if we apply 121 modular 10, the remainder will be 1. So if from the number 123, if we apply modular 10, the remainder will be 3. If it is some 1024 and we are applying modular 10, there also the remainder is 4. That means the last number. Okay. So 121 mod 10 is 1. So next what I am doing is I have to convert 121 to 12. I have to convert 121 to 12. Acknowledge Jose,
Yes, sir.
how to convert 121 to 10? Sorry, 121 to 12. If we apply some operation, we can convert 121 to 12. What is that operation? Acknowledge.
Sir, no idea, sir. No idea, sir.
So you just think about all the operators. So what is 121 and what is 12? Okay. Alex.
Just one digit difference.
Yeah, 1 digit difference. How to get 120 12 from 121? Alex,
Yes, sir.
is there any way to extract 12 from 121?
Arena, sir.
Okay, no problem. So suppose I am doing one thing, 121 divided by 10. I will get 12. Suppose then I am performing mod 10. I will get 2. That means I am extracting the numbers from right to left. I am extracting the numbers from right to left. Then I have to convert this 12 to 1. For that I have to do 12 divided by 10. There I will get 1. Again I had to perform 1 mod 10. That is 1. So I extracted from right to left. So when I have to stop this process, when it reaches this point, So now it is 1. So what is 1 divided by 10? 1 divided by 10 is 0. So when it reaches 0, we can stop this operation. So here I have some repeated operation. Finding modular, then division, again modular, then division, again modular, then division. So I have to perform some repeated division operation and modular operation. So I'm writing the program. Main. I'm declaring one variable. So here I have only explained about finding reverse of a number. We will check the palindrome after that. I'm declaring a number int n. Printf. Enter a number. Scanf. Percentage d, comma, ampersand n. So I'm writing a while condition. K equal to n mod 10, n equal to n by 10, printf percentage d, comma k. Palindrome dot c. So you just compare this program with this example and try to find the condition. I have written nothing inside while condition. So what will be the text expression? Try to find it. Varsha, Shibu,
Yes, sir.
what will be the condition? Can you predict that condition?
Mm,
Yes, just to say what is in your mind, that's enough. So from that we will, if it is wrong, we will correct it.
Don't know.
Okay, just listen here. So in this example, somebody is saying factorial n equal to 0. Shashikant,
Yes, sir.
how you got that one? Factorial n equal to 0?
If it is n is equal to n divided by 10, so then I thought it will be that.
Okay, it is not related to factorial. Okay, Varsha, you can unmute the mic. Okay, always I want to say don't know is an answer. So you have to say some answer. So anyway, the number is 121. After that, that 121 becomes 12. After that, it becomes 1. Then then in 1 by 10, it becomes 0. So when it becomes 0, I'm stopping this repeated operation. I already told you there is a repeated operation of modular operation and division operation. So when it becomes 0, we will stop the operation. So now can you say the condition?
And n equal to 0.
N equal to 0 means here initially n is 121. So when n is 121, it will not execute these steps. So here it is non-zero. That's why I divided by 1. Here 12 is non-zero. 121 is non-zero. So what will be the condition?
N not equal to 0.
N not equal to 0. Okay. So I am only doing the reverse of a given number. So k is not declared. Missed a semicolon here. So I am entering a number 1, 2, 3, 4, 5. So now I got reverse of that number 5, 4, 3, 2, 1. Actually, what I am doing is I am printing each and every number after the number. This we can't say 54,321 as a single number. Actually, it is 5, 4, 3, 2, 1 because I am printing it as 5, 4, 3, 2, 1. So I am making some more modification. I am declaring one more variable called reverse. And I am initialing it as 0. Rev equal to rev star 10 plus k. I am writing it as rev star 10 plus k. Here I am writing printf percentage %d comma rev. So I just watch it carefully. I have written this statement outside the for loop. Outside the for loop. So listen carefully. I have declared one more variable called rev. Initially it is 0. I will try to explain with the help of an example. 1, 2, 3. K values are there, n values are there. K equal to n mod 10. Here n equal to 1, 2, 3. K equal to 1, 2, 3 mod 10. So k equal to 3. n equal to n mod 10. Sorry, n equal to n divided by 10. So 123 divided by 10 is 12. REV equal to REV star 10 plus k. What is REV now? It is 0. 0 star 10 is 0. 0 plus k, k is 3. So reverse becomes 3. Again, we will check whether n not equal to 0. 12 not equal to 0 is true. So again, these three steps are executed. K equal to n mod 10. N is now 12. 12 mod 10 is 2. So k becomes 2. N equal to n by 10. N becomes 1. Rev equal to rev star 10 plus k. Now reverse is 3. 3 star 10 is 30. 30 plus k. K is 2. So it is 32. So this 3 becomes 32. Again we will check the condition. N not equal to 0. 1 not equal to 0 is true. K equal to n mod 10. N is 1. 1 mod 10 is 1. So k becomes 1. N equal to 1 by 10. 1 by 10 is 0. 1 by 10 is 0. REV equal to REV star 10 plus k. REV is 32. 32 star 10 is 320 plus k. K is 1. So 320 plus 1, that is 321. Again we will test the condition. N not equal to 0. Now n is 0. So these statements will not execute anymore. It will print this statement. Printf %d, REV. In REV I have 321. So that 321 will be printed. So any doubt in finding reverse of a given number? Please respond. If it is clear, just type clear in the chat box. So I got only some 9 responses. That means remaining some 25 people didn't understand anything. So that's what I have to interpret from that. So those remaining persons have some doubt. So what's your doubt? Please ask. Sham Santosh,
Yes, sir.
any doubt in this program?
Yes, sir. Mansley.
Okay. So now I have to check whether it is a palindrome or not. So how to check it? Mayank Raj,
Yes, sir.
how to check? So here palindrome means reverse and its number will be same. So here I found reverse. So how will I check it?
If n equal to REV,
Okay. Okay, wait 1 minute.
then it is
If
a palindrome.
n equal to REV,
R,
printf.
it is a palindrome.
Okay, 1
The
minute.
number is palindrome.
Okay. Printf palindrome. Then what will I write?
Else not palindrome.
Else
Printf not palindrome.
palindrome. Okay. So first I will execute the program. So I'm entering number 121. So what is the expected output? The expected output is, it's a palindrome. So I got not palindrome. So your thinking is correct, your logic is correct. But the thing is, so you just notice the example. In the end, n becomes 0. From 123, the n becomes 0. So after executing this loop, always the value of n will be 0. So no meaning in comparing that n with reverse. There is no meaning in comparing with n with reverse. Actually, the problem is the n value get changed. So after this loop, the n value will get changed. So we can't compare it with n. So what I am doing is, so before executing the while loop, I am storing n in another variable, t equal to n. So I have another variable called t. So before executing the for loop, the n value is 123. So t also will have 123. So here only n value is changing, not t value is changing, but because already I have stored n value to t, so later I have to compare it with t. Instead of comparing it with n, I have to compare it with t. So I'm giving some slash n here. So now just check the output. So here t is not declared, so declare it. Entering a number 1 to 1. So it is saying it is a palindrome. Let me try another number, 14541. So it is also a palindrome. Then I am trying single digits, 9. 9 is a palindrome. Then I am trying 1, 2, 3, 4, 5. It is not a palindrome. So I got not palindrome. So any doubt you can ask. In any statements, if you have any doubt, you can ask. So here I hope you understood why I replace n equal to REV with t equal to REV. Because before the n value get changed, I stored that n value to t. Later I compared reverse with that t value. Any doubt? So I am moving to the next program. Program to generate Fibonacci series. Okay, first I will explain what is a Fibonacci series. So it's a series of numbers. Always the first number will be 0. Next number will be 1. So only thing we know about Fibonacci series is first two numbers. First term is 0. Second term is 1. Third term will be 0 plus 1. That means sum of previous two terms. 0 plus 1 is 1. Similarly, fourth term is sum of previous two numbers. 1 plus 1, that is 2. Next term will be sum of previous two terms. 2 and 1, that is 3. Next term is sum of previous two terms. Next term, 3 and 2. 3 and 2 is 5. And it goes like this. So we have to generate this Fibonacci series with the help of a C program. Mary Elena,
Yes, sir.
what will be the input of this program?
Input.
Okay, no problem. Here, number of terms is the input. We can mute the mic. Here, number of terms is the input. So if I input 6, the output will be 0, 1, 1, 2, 3, 5. 6 terms will be printed. If the input is 7, it will print one more element. What will be that element? 5 plus 3. 8 will be printed. So that is the output. So we know the first term. We know the second term. we directly know the first term and second term. From that only we are generating third term onwards. So I will write the program. Fib.c, I'm just writing Fibonacci.c. Main. Int n. Print f. Enter value of n. So I am declaring two more variables, n1, that means first term, we already know n1 is 0. I am declaring second term also n2, we already know n2 is 1. So here I have to repeatedly execute some statements. I have to repeatedly execute some statements. So first two terms we know. That means from third term onwards, I have to execute 3, 4, 5, 6, 7. From third term, I have to execute. If after some values, if it is n, I have to execute up to n. So I have to perform some repeated operation from 3 to n. From 3 to n means I can write a for loop. Gogul Krishnan.
Yes, sir.
So how will I write that for loop? I have to make a for loop for executing from 3 to n. So how will I write that for loop? For that means the valid I values are 3 to n. So how will I write for?
I is equal to, sorry, n is equal to, I is equal to 0.
I equal to not 0, I equal to 3 because I am executing from 3 to n.
Yes, I is equal to
3
I less than or equal to
less than or equal to
n.
n I plus plus. Okay. Here I am dealing from third term to nth term. Third term to nth term. So before that, suppose the input is, you just imagine I am giving input n as 1. N as 1 means what will be the output? 0 will be the output. So if I give n as 2, then 0 and 1 will be the output. Zero and n will be the, 1 will be the output. So I am adding some more conditions. If n equal to 1. That means only one term, printf. Percentage d tab, space, comma, n1. Because we already know what is the first term. If n greater than 1. I will explain the program later, that time it will be clear. Printf percentage d space percentage d space comma n1 comma n2. Or here I can use else also. So I'll explain the logic later with the help of example. So here I am writing some statements. So from third term, how to calculate third term? Third term will be sum of first and second term. So I am declaring one more variable, n3, n3 equal to n1 plus n2, because you can consider this n3 as the current term and n1 and n2 as previous two terms. Just imagine like that. n3 as the current term and n1 and n2 as the previous two terms. Then I am printing n3, printf percentage d space comma n3. Then what I have to print? I have to print another term, or here you just imagine I have to print fourth term. So here the current term means, so when I am trying to print fourth term, the current term becomes n4. So but in the program it is written current term, the variable which represent current term is n3. So n1 and n2 are the previous two terms. So n2 will get a new value. So it will be clear when you see the example. n2 equal to n3 and n1 equal to n2. So just listen carefully. I have some variables n1, n2, n3, and I have a variable I. Suppose I have given an input 5. That means I have to print 5 elements in Fibonacci series. So initially n1 is 0, n2 is 1, n is 5, n equal to 5. If n equal to 1, this condition is false. So this statement will not be executed. Else printf percentage d n1 and n2. So n1 and n2 will be printed. So in the output 0 and 1 will be printed. Then this for loop will be executed for I equal to 3. So initial value of I is 3. I less than or equal to n. 3 less than or equal to 5 is true. So it will execute these statements. N3 equal to n1 plus n2. n1 is 0, n2 is 1. So n3 is also 1. That value will be printed. So 1 is printed. Next, n2 equal to n3. That means the value of n3 will be stored in n2. What is n3? So this 1 will be stored in here. Actually this one is coming here. Then n1 equal to n2. The value of n2 is stored in n1. So here n2 is 1, n1 is 0. It is 1. So the current term becomes previous term and previous term to the current term becomes previous to the previous term. So I hope from this diagram it is clear. Again, I plus plus will happen. I becomes 4. Then again the condition will be tested. 4 less than or equal to 5 is true. 4 less than or equal to 5 because n is 5. n3 equal to n1 plus n2. n1 is 1, n2 is 1. So n3 becomes 2. Printf percentage d comma n3. n3 will be printed. So 2 will be printed. Then again n2 equal to n3. So here 2 will come. This 2 will be stored here. n1 equal to n2. n2 is here. There is a small correction. The order is very important. I just n1 equal to n2, n2 equal to n3. So I will explain it again. I have n1, I have n2, I have n3, I have I. Just imagine, for simplicity I am taking only 4, n equal to 4. n1 I know initially it is 0, n2 it is 1. So we already discussed about these conditions. So anyway, it will execute else part. n1 and n2 will be printed. 0 and 1 will be printed. I equal to 3. Initial value of I is 3. 3 less than or equal to 4 is true. So these statements will be executed. n3 equal to n1 plus n2. So n3 becomes 1. n1 equal to n2. n2 value of 1 is stored in n1. So 1 will come here. n2 equal to n3. So this n3 value will be stored in n2. So here 1 will come. Again the condition will be checked. Sorry, again the for loop will increment. I becomes 4. n3 equal to n1 plus n2. So in the earlier case I missed on print statement. Here this n3 will be printed. So it will be 1. So now these two will be added. n3 equal to n1 plus n2. It will be 2. Printf percentage d comma n3. So that 2 will be printed. n1 equal to n2. So n1 becomes 1. n2 equal to n3. n2 becomes 2. So again this I value will be incremented. I becomes 5. 5 less than or equal to 4 is false. So nothing more will be printed. So the final output will be 0, 1, 1, 2. Now I will execute the program. Some errors are there. I is undeclared. Some problems are there. I will check it. So here I didn't read that n value. I missed the scanf state. Yeah. Scanf percentage d comma ampersand n. Okay. So I'm giving some 4. So I got 0, 1, 1, 2. I'll give some 8. 0, 1 are the first two terms, and 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, 5 plus 8 is 30. So I hope you understood Fibonacci series. Any doubt in any one of the statements? So this order is very important, n1 equal to n2 and n2 equal to n3. If you reverse the order, the new value of n2 will be stored in n1. The new value of n2. That means if I reverse the order, n2 equal to n3 first, then n2 contains n3. After that only I am storing n2 to n1. That is, in the net result, n3 will be stored in n1.